fractal, 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 fractal. They are fractal. Math with Max. Fractals.
Hi, I'm Max, and these are fractals. A fractal is a rough or fragmented, self-similar geometric shape that's based on an equation that undergoes iteration. Yeah, it's confusing. Let's take a closer look at that.
So the definition of fractal is pretty awkward. We'll break it down to make it less awkward. Once we split it into a couple parts, it'll be easier to understand. So the parts of the definition is rough or fragmented, geometric shape, self-similar, and an equation that undergoes iteration. So we'll start off with defining rough, fragmented geometric shape. A geometric shape is something like a circle, or a square, or a trapezoid, or a rhombus. Something that is not geometrical is something like this, which doesn't have any defined sides. It's rough, fragmented. So self-similar means that it's a shape that repeats itself within itself. Kind of like this triangle here. We have the top part, it makes a triangle like that. And we zoom in on that top part, it makes a triangle like that. And we keep doing that until infinity, which means forever.
Yay, forever.
So our next part is an equation that undergoes iteration. This means that the equation repeats indefinitely, which also means forever. An equation is something like this, but this equation is different. It's more like this, where x equals the input and y equals the output. Now with the fractal, you put in x, it changes a little bit, and you goes to the output. And you feed the input back into the output, and you keep doing that over and over again until you end up with a pattern, which is a fractal.
Yay, fractal.
So now that we know a little bit about fractals, let's take a look at some of them in their structure. We'll start off with some easy ones, so we could kind of ease you into it. So let's take a look at some simple fractals.
Simple fractals.
One of the more common ones is called the Sierpinski triangle. The Sierpinski triangle starts out with an equilateral triangle and another one inside it, creating the common recurring symbol in a popular video game series. Next, we repeat the same process in each of the other little triangles. Until we end up with a very complex structure like this one.
Ah!
Alright, so let's move on to our second simple fractal, called the T-square. The T-square starts off with a regular square, and then we add a similar square onto each corner of the main square. And that goes on to the next step, where we add squares, similar squares, onto each of the corners of those squares. And that just keeps going on until forever.
Ah!
Alright, now I'll demonstrate Swedish mathematician Helga von Koch's famous fractal, the Koch star, also known as the Koch snowflake. We'll start with an equilateral triangle, but let's just look at this top segment. If we split this segment into 3 equal parts, and use the middle segment as the base for another equilateral triangle, we'll just end up with something like this, a figure that resembles a star of David. If we repeat that algorithm, we'll come up with this, and this, and this. Now, as we keep going, it's going to look less and less different each time, because you're only making minor changes. So, that is the Koch snowflake. Yay! Jump, jiggy
Fractal.
fractal. It is now time for fractals in nature. Did you know that this tree is a fractal? Yes, things like ferns, lightning bolts, and this broccoli plant are all fractals. Scientists even conduct experiments on bacteria in petri dishes. Sometimes they form fractals. This happens in ferns and other plants because the sprouts stemming off from the center are actually adorable miniature versions of the full plant. Aww. Let's take a look at that broccoli again. That is Romanesco broccoli, friends. It looks delicious. This has been Fractals starring in nature. Yeah.